Hey y'all, this video is on geometric sequences. We're going to learn about explicit and recursive formulas. A geometric sequence is a list of numbers in which the ratio of consecutive terms is a constant r. In the example 1, 2, 4, 8, and 16, we can find r by dividing consecutive terms. So I'm going to pick two consecutive terms, 4 and 2. Notice I divide 4 by the previous term, 2. 4 divided by 2 is 2. So that sequence was formed by multiplying by 2 each time. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 16, 8 times 2 is 16, and so on. In the second example, I find the common ratio the same way. I take a number in the sequence and divide by its previous number. So I'm going to pick the last two that I see. -1 divided by -2 is positive 1/2. So that's a sequence where the common ratio was a fraction. In the last example, I find r by picking two consecutive terms. I'm going to pick the two in the middle. 1/6 divided by 1/2. Notice this time I express my ratio as a division problem because it's fractions, it's just easier. 1/6 divided by 1/2 is 1/3. So again, I have a common ratio. That's a fraction. One of the following sequences is geometric and the other is not. So what we're looking for is a common ratio. If you divide 3 by 1, you get 3. If you divide 9 by 3, you get 3. But if you divide 12 by 9, you get, let's think, 4/3. Because the division of consecutive terms didn't result in a common ratio, a common answer, this is not a geometric sequence. So we know automatically that B is the correct answer. But let's go ahead and verify that. R equals, well, 3 divided by 1 is 3. 9 divided by 3 is 3. And 27 divided by 3 is 3. So consecutive terms form a common ratio, and that means it's a geometric sequence. A brief mention of notation. It's traditional to use the letter A to represent the terms of a sequence. The subscripts indicate the position number. This trio of strangeness here is simply a way of expressing some general term where K is any number. The recursive formula tells us that the nth term, where n could be any number, 27, 462, whatever, the nth term is the previous term. N minus 1 indicates the term before the nth term, times the common ratio r. Common ratio. Now, we're going to practice using that to generate the terms of a geometric sequence. We're being asked to find the next 5 terms of these two geometric sequences. So the first thing we're going to establish is the value of the common ratio. Remember, to do that, we pick consecutive terms and we divide. The common ratio here is 2. So the recursive formula tells me that I multiply 8 by 2, and then I multiply 16 by 2, and then I multiply 32 by 2, and so on, and generate the next 5 terms of that particular sequence. In the second example, notice your terms are getting smaller. That means r is going to be a fraction. 64 divided by 128 is equal to 1/2. So they multiplied by 1/2 each time here. 32 times 1/2 is 16, times 1/2 is 8, times 1/2 is 4, times 1/2 is 2, times 1/2 is 1. Now, what if we want to find some random term that's way on down the road? So if I want to find the 100th term, do I really want to find the 99 previous terms in order to find the hundredth. I don't. That's a lot of time and multiplication. Well, we have an explicit formula which relates the nth term to the first term times the common ratio raised to the n minus 1 power. Now realize, please, that this n and this n are the same. So if n on the left is 6, then the n on the right is 6, and 6 minus 1 is 5. So let's take a look at an example, and then we'll practice that. All right, here we go. If a sub 1 is 0.01 and r is 10, find a sub 6. So we're going to plug in the formula. A sub 6 is a sub 1 times r, which is 10. And now we raise 10 to the power that's 1 less than 6, or 5. And 0.01 times 10 to the 5th is 1,000. Now, to make sure you believe that, and also to show you the brute force way of doing the problem, we're going to multiply 0.01 by 10 and create the sequence the brute force way. 0.01 times 10 is 0.1. 0.1 times 10 is 1. 1 times 10 is 10. 10 times 10 is 100. And 100 times 10 is 1,000, which is the same answer we got using the formula. Now we're going to practice that, and we are. Find the indicated term of the geometric sequence. 486, 162, etc. And we're looking for a sub 8. Well, according to the formula, a sub 8 is equal to 486 times r to the 7th. Now, to find r, we divide consecutive terms. It doesn't matter which two you pick. I'm going to take these two because they're the smallest two. 18 divided by 54 is 1/3. Notice I put the 1/3 in parentheses. That's very important for calculator use. So 486 times 1/3 to the 7th gives us our 8th term, which is 2/9. In the second example, 5, 10, 20, 40, you may notice right away that r is equal to 2 because the numbers are doubling every time. We're looking for a sub 24, so we take the first term 5 and we multiply it by r, which is 2, to the 23rd power. And that's equal to a really big number, 41,943,040. Let me double check that. Yes, that's it. All right, in the last example, I want you to notice that the terms alternate in sign, positive, negative, positive, negative. R will tell us why. I'm going to take consecutive terms, the first two. I'm going to divide -3 by 1, and I get an r value that's negative. So a sub 12, the 12th term, is equal to the first term times the r value, -3 raised to the 11th power. Notice I put the -3 in parentheses, again important for calculator. And this gives us the answer 177,147, and oops, it's negative. All right, and that is the use of the explicit formula for geometric sequences. Thank you for watching.